Hello friends, today we will discuss that when a mountaineer is suddenly climbing a mountain or a high altitude, why they face the breathlessness or hypoxia. In the ambient air, there are two important gases. One is oxygen, it is 21%, and nitrogen is 79%. So how do you calculate the partial pressure of oxygen in inspired ambient air? It is by partial pressure of oxygen is equal to fraction of oxygen in the air into the atmospheric pressure. And here we are taking at sea level, the atmospheric pressure is 760 millimeter mercury. So the partial pressure of oxygen what we get in the sea level is 159 millimeter mercury, or the oxygen tension is 159 torr. So you can see here that at the mouth of a person at start of inspiration, the partial pressure of oxygen is 159 millimeter mercury or 159 torr. From the equation we can see by increasing or decreasing the fraction of oxygen or the barometric pressure or atmospheric pressure, we can increase or decrease the partial pressure of oxygen. So oxygen tension in the mouth can be altered by two ways: by fraction of oxygen in the inspired air or changing the barometric pressure. So what is happening in high altitude? In the high altitude, the ambient oxygen tension is decreased due to the atmospheric pressure will decrease with high altitude. So we suffer from hypoxia or lack of oxygen at the tissue level. Now come how to compensate it by alveolar gas equation. In alveolar gas equation you can see partial pressure of inspired oxygen is equal to fraction of oxygen in the inspired air into atmospheric pressure minus water vapor pressure. So if PaO2 is equal to PiO2 minus PaCO2 by R, this PaCO2 is the alveolar carbon dioxide. So by hyperventilating, what